Okay, so now the next formula में क्या है? Number of lighting fixtures. So what is the formula? L into B into lux level divided by CUF into MF into fixture type into lumen output. So L into B 4.1 into 3.7, lux level for the entrance wall is 300 divided by CUF, coefficient of ventilation factor कितना आया मुझे? 0.54. Fixture type I had taken one fixture because it's a residential building. The lumen output of that light is how much from the catalog? From the catalog we had seen. Where's the catalog? Yeah, when we had taken this light, the lumen output is how much? 3350 is the lumen output, and the maintenance factor was how much? 95% is the maintenance factor for with the light which we had taken. So now substituting in all this in that, so length into width into lux level divided by CUF is 0.54, fixture type is one fixture type, the lumen output is 3350, the maintenance factor is 95%. So I considering all this, I got the total number of lights as 2.64. That is, we have taken the number of lights are 3. So total number of lighting fixtures required in this room of 36 watt light is how much? 3 numbers of light we require in this room. Am I clear? Any questions? Hello.
Hello, sir.
Yeah.
Always we need to take lighting fixture always one, or it's based on client requirement.
No. See, that's what I'm telling. I told you, if it's a residential building, maximum we take it as in one fixture type. Okay. If it's a commercial building, if your occupancy area is bigger, and if you're getting more number of fixtures, try to take 2 or 3 or 4. If suppose you have some 10,000 square, if you have an open area of just complete an area of 4,000 square feet or 2,000 square feet, then it's a bigger area, na? So at that time we need to go with some 2 or 4 fixture type. Am I right or not? So client doesn't know anything. As an engineer, you need to tell. See, generally, if you take one fixture type, if you calculated, you got some 30 or 40 or you got some 100 lights. Tell me, can you place 100 lights easily?
No, sir. No.
No. So what we are doing now? So that is the reason what we are doing. We are going with for commercial projects and all, we go with a fixture type as in 2 or 3 or 4, so that it should not be any problem, right?
Okay, sir.
Yes. Others?
इसमें पैनल्स भी 2x2 पैनल्स वगैरह भी लग सकते हैं, तो फिक्चर्स अगर कि क्लाइंट को नहीं लगाना है तो फिर उसके लिए कैसे करें?
समझा नहीं, क्या बोले?
फिक्चर्स अगर क्लाइंट को नहीं लगाना है, एलईडी अगर लगाना है, पैनल्स लाइक 2x2 पैनल्स,
हाँ 2x2 पैनल लगा रहे. हाँ.
तो वो उसके लिए कैलकुलेशन कैसा होगा फिर?
सी, अगर वो आप 2 फिक्चर 3 फिक्चर 4 फिक्चर नहीं लगा रहे, तो अगर 1 फिक्चर ही लोगे तो आपको लुमेन आउटपुट ज्यादा वाला लेना है. यू टेक एज 55 वॉट 75 वॉट का लाइट ले लो, वेर योर लुमेन आउटपुट इज मोर देन 5000 ना. एट दैट टाइम यू विल गेट मोर नंबर ऑफ लेस नंबर ऑफ फिक्चर्स ना. हियर यू कैन सी we have 6550 lumen output also. Okay, and we have something like more 8300 lumen output also.
Okay.
Am I clear?
यस.
Okay,
सो इसमें और डिफरेंट टाइप्स के लाइट्स भी अगर क्लाइंट को सजेस्ट कर सकते हैं क्या? लाइक मतलब फिक्सचर्स नहीं लगाना है तो इंडस्ट्री में सपोज में रिकमेंड करना है क्लाइंट को, और उसका फैक्ट्री है, और तो उसके लिए फिर वो
में बोले तो we can't go with FL ना, we'll go with this one, sodium vapor or mercury vapor lamp, or even
Okay.
LED will go. Okay, that is the lumen output उसका कम से कम you'll have a least to is around minimum. If you're taking minimum, it's around 5000 to 6000 you'll have a lumen output, and some light will have 11000 lumen output also.
Okay.
Okay, in that case there is no parameter, because if you're going with industry, you don't have false ceiling, right? It's a shed. Okay, where we have a chain, suspended chain, okay, lighting, or even the panel side wall mounted lights you'll have. If for industry it's not a problem, only for commercial building where you have a false ceiling, and for bigger vast area, that place only the panel mounted panel type of light which is a 4x4, or if the certain consideration where if is not giving that much of space, then we need to at least go with a 2 fixture type also we can do.
Okay.
Okay,
Okay, sir.
So any more questions on this? Okay. Now, likewise, we will do in Excel sheet with for all the calculation. Let me complete with the fans, exhaust fan, and AC calculations. Then we'll do for all the calculation for that flat. Now we got clarity about lighting calculation. Now this we are done here. I done here. Okay, but I'll tell you in the Excel sheet how do we formulate in the Excel sheet. We'll do for all the total flat calculation. Now we got the lighting calculation. Now let us go with the next one is fans calculation. Now coming to the ceiling fan calculations. Now what is the purpose of ceiling fan? The purpose of ceiling fan is nothing but to circulate the inside air itself. अंदर का जो हवा है वही हवा को फेंकने के लिए we go with the ceiling fan. To circulate inside the air, then we go with the ceiling fan. Okay. Now when it comes to the manufacturer standards, when you see the manufacturer standards, these are the tables which are given. Okay. So what is the manufacturer standard saying? Standard ceiling fan coverage. Standard ceiling fan coverage. We have three different types of fans. 36 inches fan, 48 inches fan, and 56 inches fan. In the market, you'll get three types. One is 36 inches, next is 48 inches, and the next is 56 inches fan. When you go with 36 inches fan, if your area of the room is ventilated, means area of the room is ventilated means if your room have a doors and windows. Okay, if the area of the room is non-ventilated, apart from door, we don't have any opening to that room. Okay, if its area of the room is ventilated, in terms of meters, 136 inches fan give a coverage area, will give a coverage area or will give a coverage distance in terms of length and width is 136 inches fan will give a coverage area in terms of meters is 3.67 meters by 3.67 meters. In terms of feet is 12 feet by 12 feet, means coverage area or creepage area we call. Fan जो हवा फेंक रहा है, it will give a coverage area or creepage area is nothing but 3.67 by 3.67 or 12 feet by 12 feet. Similarly, if you are going with the 48 inches fan, जब ये fan चलेगा, the coverage area is how much? 4.27 by 4.27 meters. Okay, or in terms of feet, 14 feet by 14 feet. In terms 56 inches fan again, 4.88 meters by 4.88 meters. So same in terms of feet is 16 feet by 16 feet. Agar if it's a non-ventilated room means we don't have any fresh air. अंदर का हवा कोई फेंक रहा है, तो the airflow is less in that room. So in that consideration, we take somewhat lesser distance, that is 3.05 by 3.05. Okay, in feet, 10 feet by 10 feet. In terms of 48 inches fan, 3.67 by 3.67 in 12 feet by 12 feet. Again, 56 inches, 4.27 by 4.27 in meters, and 14 feet by 14 feet in terms of feet. So this is one fan coverage area for the both ventilated and non-ventilated room. Now, when you see the next table, what is the next table specifying? The next table specifies that for a room area, which kind of fan has to be selected. What is the first table telling? One fan coverage area it is telling. Second table specifies that if you want to be more specific that which kind of fan has to be taken for that area, you can take this one, or else by default if you want 36 inches or 48 inches fan, you can take it up. But the second table specifies if you more significantly that if you want to select the fan out of these three, like out of 36, 48 or 56 inches fan, which one has to be selected? So what is it saying? Room size in square feet. Room size in square feet, we have 75 square feet, 144 square feet, and 225 square feet. If your room size is up to 75 square feet of an area, then try to select a fan in terms of meters, 6.96 meters square. Try to select a fan which is of 36 inches fan. 29 to 36 means 36 inches fan. अगर आपका room size है 75 square feet तक है, go with a 36 inches fan. If your room size is up to 144 square feet of an area, then try to select this 48 inches fan, that is 36 to 48 inches fan here. So you can go with the 48 inches fan. Then if your room size is up to 225 square feet of area, we go with a 56 inches fan. Then you might have a question, what is the consideration if my room area is more than 225 square feet? Then we all know that if your room area increases, then obviously we go with the number of fans. So it doesn't mean that only one fan will give a total area. No, if your room size is bigger than that, we go with the number of fans concepts. Okay, so the first table specifies what is the coverage area of each and fan. Second table specifies if you want to be more precise which fan has to be selected for a room area. Then the second table specifies this is a room sizes in terms of square feet, and this is a selection of fan like 36 inches or 48 inches or 56 inches fan. Okay, now let us take a small example. Calculate the number of ceiling fans for an entrance hall where the size of the room is 13 feet 8 inches into 12 feet 5 inches. My room size is 13 feet 8 inches and 12 feet 5 inches is the dimensions of the entrance hall which we had seen. Entrance hall का जो dimensions है 13 feet 8 inches and 12 feet 5 inches. So calculate the number of ceiling fans for an entrance hall where the size of the room is how much? 13 feet 8 inches into 12 feet 5 inches. And I'm considering that it is in a ventilated room. Let us consider that it is in a ventilated room. It is a ventilated room. So for the given room, that is 169 square feet. 13 feet 8 inches into 12 feet 5 inches. What are the value, guys? If you take 8 inches, so that is 8 divided by 12 plus 13. The value is 13.66 feet. In terms of feet, this is 13.66 feet. Okay, then same 12 feet 5 inches is 5 divided by 12, okay, plus 12 is 12.416 feet. 12.416 feet. Then when you multiply the total, 12.416 into 13.66, the total value is 169.61 square feet. So now I converted that in feet and inches, and I calculated the area of the room is how much. Now we got 169 square feet. The area of this room is 169 square feet. Now from the table, for a room size of 169 square feet, which kind of fan has to be selected? My room size is how much here? More than 225, na? Because sorry, more than 144. I got 169, so I need to take more than 144. So I taken this one. For this table, from this table, which fan has to be selected? 56 inches fan has to be selected. 156 inches fan. What is the coverage area? 16 feet by 16 feet, or in terms of meter, 4.88 by 4.88 meter. So 156 inches fan will give a coverage area of 4.88 by 4.88. Then how many number of fans we require for a given area of 13 feet 8 inches into 12 feet 5 inches? So for the given room, that is 169 square feet, we need 56 inches fan as shown clearly in the table 2. So 56 inches fan from table 1. For ventilated room, the coverage room size is how much now? 4.88 by 4.88 meter, or in area, or in feet. If you want, you'll get feet. So required number of fans is equal to total area of the hall divided by area required for a fan. What is the total area of the hall here? Total area of the hall is, in terms of meter, when we calculated, what is the value in terms of meter here? 4.1 by 3.7. Then y at written here is 4. Same 4.17 into 3.78. Yeah, 4.1 into 3.78 in terms of meters, divided by coverage area of 156 inches fan in terms of meters, 4.88 by 4.8. Total area of the hall divided by area required for the one fan, or coverage area of one fan, that is we got 0.66. That is approximately equal to one fan. Am I clear? Any questions?
Yeah, and suppose if it is in the hall, we also have the TV unit and sofa, the furniture. So we have to deduct that from the square feet, or the empty room we have to take into
We
consideration.
need to take an empty room.
Okay.
Okay, irrespective of your furniture, we are taking only for empty room. Just like lights, even for the lights also we are putting a furniture, right? Okay, considering that only, we calculated based upon the room size only. Okay. Any more questions? Okay, but in this there is one problem here. What is that problem? Let me tell you here. I didn't written that. Okay, I'll tell you here. Okay, generally in this, one drawback will be there. What is the drawback is, now when you see actually what is the coverage area of 136 inches fan, if you take 3.67 by 3.67, what is the coverage area if you take 3.67 by 3.67? by 3.67, that is 13.46. It's around 13.46. 3.67 by 3.67 is nothing but 13.4689. Now example, I'll tell you. Let us take a small example. There is one room. Okay, there is one room. Okay, now I provided two fans. Example. Now how you will get the distance between the fan to fan? As per the standard, if you take like this, what is the coverage area of one fan here? 13.4689. No? Okay, let me write here. Yeah, so when you see area of one fan coverage is how much? Now we have taken 13.46, right? Okay, so 13.469. Okay, I got is a meter square is a coverage area of one fan. So what is the formula for area of circle? Because fan is circulating in a circular pattern. Na? Fan will circulate the air in a circular pattern. So when you take the circular pattern, the area of the circle formula is what? Pi by 4 d square. The formula for area of circle is pi by 4 d square. Okay, is equal to the coverage area is how much? 0.469 meter square. Okay, area of circle, fan is circulating the air in circular pattern, so area of circle is equal to pi by 4 d square. So pi by 4 d square, one fan coverage area is 13.469, so pi by 4 d square is equal to 13.469 meter square. Then I calculated, when I calculated the d square value, so what will be the d square value? 13.469 into 4. Okay, 13.469 into 4 divided by pi value is 3.14, that is equal to d square value is how much now? 17.157, okay, meters square. This is the value. But d, I want d. When I take d, what will happen? Under root of 17.157 meter square. When I take under root of 17.157 meter square, just a minute. So under root of 17.157 meter square. So what is the value which I'm getting is 4.12.
4.5.
4.14. Okay, 4.14. That's all, enough. 17 under root of 17.157 is nothing but equal to
4.14.
Yes, sir.
4.14.
4.14.
Okay, meter, because root and square will get cancelled. 4.14. Now what is d? D is nothing but the distance between fan to fan. Okay, d is nothing but the distance between, okay, the fan to fan. So when I take the distance between fan to fan, what is the standard distance as I got it here? 4.14. So now if I take according to 4.14 as a meters distance between fan to fan, yeah, if I take the distance as in from here to here, distance between center of the fan to another center of the one fan, C to C, the value is how much? 4.14. But in this there is one drawback. What is the drawback is, when this fan is circulating, it will start giving the air in this way. Okay, then when this fan is circulating, it will start giving the airflow in this way. Between the two fans, we always have one zone called dead zone. We call dead zone. Okay, so between the two fans where your intensity of airflow is less, so we have a zone called dead zone. So to avoid this dead zone, what the people generally will do is, in a standard, they'll go with the distance between one fan to another fan is around 3.5 or 3.6 meters. They'll take it up. Why? Because when you're reducing the distance between fan to fan, the airflow at this point will have a more, so that a person who is standing in between the two fan, you'll also have certain airflow which is coming on. So that is we call dead zone. So considering this parameter, the standard distance between the fan to fan is will take some 3.5 or 3.6 meters is in a maximum, and distance between wall to the fan, the distance between wall to the fan is half, that is d by 2. So if you take d by 2, that is around 1.75. Okay, 1.75 which we take it up, that is a maximum. Okay, and minimum is we take 1 meter as a minimum distance between wall to the fan. Okay, but the maximum distance is around 1.75 distance we take it up from, that is from wall to fan, the distance, and distance between fan to fan while placing we take as in 3.6 meters. Okay, am I clear?
Okay, yes.
Okay, now so the next is fans calculation we are done. Let me open a small Excel sheet for Excel sheet. This exhaust fan calculation. Generally, exhaust fan we don't calculate, but I have a small Excel sheet. Just me open that. Just a minute, guys. Just a minute. I'm opening an Excel sheet. I don't know where I put it up. I'm just searching.
सर आपने जो बताया 3.6 मीटर होना चाहिए
कौन सा?
डिस्टेंस बिटवीन फैन,
यस,
तो वो 36 इंच फैन के लिए या फिर वो 48
कौन
के
सा भी
लिए?
फैन हो, इवन द 58 इंचेस फैन लोगे, द मैक्सिमम इज दैट.
ओके।
Okay. Okay. Now, when you see this, actually, this is a table. Generally, when you're going with exhaust fan calculations, it is done actually by the HVAC engineers. But if you want to do, okay, if you want to calculate even for the toilets and all, we can calculate even from this one. So, as per the CPWDs, that is Central Public Work Department, the standard is given. So, when you want to calculate the exhaust fan capacity, when you want to calculate the exhaust fan capacity, so first of all, what is the purpose of exhaust fan? The purpose of exhaust fan is nothing but to remove the foul air from inside that room, and to supply, to remove the foul air. When you're removing the foul air, what happens? Automatically it will create a negative pressure. When it is creating a negative pressure, positive pressure will automatically enters into the toilet or kitchen. Like example I'm telling, there is one toilet. अब ये टॉयलेट में एग्जॉस्ट फैन लगा रहे हैं. When you're providing an exhaust fan, तब क्या होगा? अंदर के हवा को निकाल के बाहर फेंकेगा. तो जब क्या होगा? नेगेटिव प्रेशर क्रिएट करने से क्या होगा? एटमॉस्फेरिक प्रेशर जो भी है from hall or any other rooms, it will start entering inside to that room. Then obviously the positive and negative pressure will get balanced. Okay, so now we need to calculate the size of the exhaust fan required for a given room size. Okay, now here you can see, you can select the kind of application of the room. Okay, what is the application of the room which you're taking? Like example, I'm taking for toilet. Okay, toilet domestic. Okay, the toilet domestic, there the room size is 10 feet by 12 feet and the height of the room is 3 feet. Now when you go with the size of the room, what is the size of the room? Cubic feet. Length into width into height, that is cubic feet. That is 10 feet into 12 feet into 3 feet, that is equal to 360 cubic feet. Now what is this fresh air exchange rate in room? What do you mean by this fresh air exchange rate in room is, for every room as per the CPWD, air changes per hour. ACH means air changes per hour. Okay, in 1 hour, what are the number of air changes that has to be done? Okay, that is called as an air changes per hour as per the CPWD. So when you see shower area, what is the air changes rate per hour? 15 to 20 air changes per hour has to be completed. Consider the maximum 20. Like for bathroom, what is the air changes per hour? 6 to 10. On average, let us take 8. Like for all the rooms wherever you're providing an exhaust fan, we need to take as per the CPWD standards, local standards. So number of air changes per hour. So as it's a toilet, I taken 8. So when I substitute 8 air changes times per hour, so what is the total required size of the fan? So required size of the fan is equal to size of the room in terms of cubic feet. And what are the air changes per hour? 8. So when I multiply that C8 into C9, that I got 2880 cubic feet per hour, CFH. Now cubic feet per hour in terms of CFM, we call cubic feet per minute. Okay, in terms of cubic feet per minute, so it is divided by 60, we'll get in CFM. That is 2880 divided by 60, that is CFM, that is 48 CFM, 48 cubic feet per minute has to be done. Okay, then cubic meter. Okay, this is in feet and this is in meters, so that is into 1.6990, because foot to the meter, that is 82 cubic meter per hour. Now when it comes to size of the ventilation fan, अभी मुझे कितना CFM चाहिए? I required a CFM in terms of 48 CFM. मुझे मार्केट में वो फैन का जो है CFM कितना देना चाहिए? 48 CFM देना चाहिए. So now coming to this catalog, manufacturing company catalog, here the standard exhaust fans are there in terms of CFM. Okay, in terms of CFM, what is the CFM we require? We require some 48 something is there, ना? 48 है ना? Yeah, we require 48 CFM. Give me 2 minutes. 48. Okay, 48 is something like 19, 54, 33. Okay, so I think I need to go with 54 only. I need to go with 54. So when it takes 54 CFM, okay, so what is the sound level of that fan? 60 to 65 sound level of the fan, that is decibels. Then fan dia, okay, fan dia in mm or inches, 380 mm or 15 inches the diameter of the fan. Speed RPM is 1400. The power in wattage is 160 watt, and if it's a single phase current is 0.75 amps. CFM 13, 29, 54, 33, 65. Yeah, same. We got 48 means I'm taking 54 because nothing is there after 33. The next is 54 only. So when it comes to 54, so for 54, the input power is 160 wattage. So 160 wattage is single phase and 0.75 is the current. Okay, and in that you will get three phase also. It is there. No, both are single. Three phase also there. Okay, 150 wattage three phase also there. That is 0.45. Okay, I'm a clear this. So based upon this table, so or generally as if it's a residential building, we go with a normal 75 wattage or 65 wattage, we'll take it up. But if you want exactly according to the CPWD standards, as per the standards, then whatever the toilets which you're taking, that we need to consider this as a table and we calculate the fan capacity. Any questions?
No, sir.
Others?
No, sir.
Okay.
Fan, where is the fan capacity we say? I mean, like we
Fan
get
capacity?
6 inch by 6 inch or 8 inch by 8 inch.
Which one? You're talking about ceiling fan or exhaust fan?
Exhaust fan, exhaust fan.
Here we got 380 mm in terms of dia. This is a fan dia, it's an exhaust fan, it's in dia. So we got 380 mm or 15 inches fan.
Got it, got it.
Okay. Okay. Now we're done with the exhaust fan calculations. Okay. Now the next one is, okay. Likewise, I calculated the fans for all the rooms, and for the some places like toilet 1, toilet 2, we don't require. I just taken as 0. Utility also 0, and kitchen as per the client requirement whether to take or not. So I didn't taken here. So I taken fans and exhaust fan calculated, and the entrance hall master bedroom we don't require exhaust fan. So I taken 0, 0. Utility we don't require, bedroom we don't require, dining area we don't require. So I taken 0. Only in the toilets and kitchen. Okay. Now let us calculate the total lighting load, guys. Okay. So total lighting load is number of FLs into FL wattage plus number of CFL into CFL wattage. Now these rooms I taken CFL, guys. Okay, like toilet 1, toilet 2 and utility I taken the CFL of D type 18 watts, like in the lamp data, because that are smaller rooms, na? So smaller rooms में अपन को FL की जरूरत नहीं है ना. So I taken CFLs. So which one I taken? D type. This is CFL. Yeah, in the CFL I taken D8, D type, 18 watts I taken. Okay, where the lumen output is 1200 and 80%. Then according to that, when I calculated, I'll do this in Excel sheet also. Okay, he got some 111. So now when it comes to total calculations now, so total calculation is now how much? Number of FLs into FL wattage plus number of CFL into CFL wattage. So total FL, how many we got the total FL? Adding up the total FL. So 3, 4, 5, 6, 7, and dining area 8, 9, 10, 11. So 11 in FLs and 3 CFLs. So 11 into 36 plus 3 into 18. The total lighting load is 450 watts. We will do this in Excel sheet now. Then ceiling fan again, number of fans into fans wattage, 4 into 80, 320. Number of exhaust fans into exhaust fan wattage, I taken 75 wattage. So 225 wattage. Now coming to the next one is sockets. Lighting load means the loads which are less than 100 watts. So what are the loads which are less than 100 watts lighting load? What are they, guys? Fans, FL, lights, fans, exhaust fan, as well as in sockets. Now coming to the sockets, how we define the sockets in each and every room, already I told you. Do you remember or not?
Yes.
Okay,
Yes.
so normal socket already I told you. So entrance hall 4 sockets, master bedroom 3, bedroom 2, toilet and bathroom 1. So एक entrance hall था 4, master bedroom में 3, 4 plus 3 7, और bedroom पहले toilet 1, toilet 2 है 4. Okay, here I'll write it here. Here I'll write एंट्रेंस हॉल 4 सॉकेट्स, मास्टर बेडरूम 3 नॉर्मल सॉकेट, टॉयलेट 1 में 1 सॉकेट, टॉयलेट 2 में 1 सॉकेट, यूटिलिटी में नॉर्मल सॉकेट नहीं है, पावर सॉकेट, बेडरूम 2 नॉर्मल सॉकेट, डाइनिंग एरिया 2 normal sockets. So I had written as in 2 normal sockets in the dining area. Kitchen no normal socket, only power socket. So what is the total? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total 13 sockets. Socket normal socket का wattage क्या है? 100. So 13 into 100, that is equal to 1300. So now what is the total lighting load? Fixture loads plus ceiling fan load plus exhaust fan load plus 6 amps load. Fixture load कितना है? 450 watts. Ceiling fan load आ गया 320. Exhaust fan load आ गया 225. और नॉर्मल सॉकेट का लोड आ गया 1300. ऑल टुगेदर व्हाट इज द टोटल लोड? 2295 इज द टोटल लोड ऑफ द लाइटिंग. ओके, एनी क्वेश्चंस?
No, sir.
No.
Okay, now we got the this lighting load. Now the next one is power sockets. Now what are power sockets? We need to consider the sockets also, na, here power sockets. So when it comes to power socket, already I had given the power sockets according to standards in each and every room. Okay, so now first of all I told you this already, but I'm repeating once again. What are power loads? Are the loads where we are going to take the power from socket for your electrical appliances. So while considering the loads for estimating the power, we don't consider the appliances, we need to consider only socket load. Already I told you this, but I'm just repeating once again. Normal socket, what is ampere rating? 6 amps 100 watts. Power socket 16 amps 1000 watts. Universal 20 amps 1500 watts. Now when it comes to standard, for every room the standard sockets is given, but if you don't know the application of the room, what is the formula to calculate the number of sockets? I told you already, 2 into L plus W15 open area number of sockets. Okay, so now according to this, now let us place the sockets. पावर सॉकेट भी लगा देंगे अभी. तो पावर सॉकेट कितने आएंगे? एंट्रेंस हॉल में एक पावर सॉकेट, मास्टर बेडरूम में एक पावर सॉकेट, टॉयलेट 1 में एक पावर सॉकेट, टॉयलेट 2 का एक पावर सॉकेट, यूटिलिटी फॉर वॉशिंग मशीन 1 पावर सॉकेट, बेडरूम 1 पावर सॉकेट, डाइनिंग एरिया 0, kitchen it's around 4 to 6. So I don't know how many I consider. 1, 2, 3, 4, 5, 6 plus 5 I think so. That is 11. So I taken 5 to 6 now. Kitchen is 4 to 6. So I taken 5. So how much I taken here? I taken 11. Yes. Okay. Because as per the standards in a kitchen is 4 to 6. 4 to 6 is as per the standard. So I taken I think 5 sockets I taken here. So when you add up that, so total is how many? 1, 2, 3, 4, 5, 6 plus 5. That is equal to 11 sockets. So what is the power socket? What is 1000? So I taken total 11 into 1000. That is equal to 11,000 watts or 11 kilowatts. So I got the total lighting load, power load. Now the next is we need to calculate about the, we need to know about the AC load. We need to know about the AC load. Now what is the purpose of AC? The purpose of AC is to achieve the comfort temperature for human being. So that is 22.5 to 26. Okay. See, generally we know that the outside temperature, the ambient temperature is around 45. If you're going with summer, it's more than 38 up to 40 or 50. So the purpose of air conditioning is nothing but to achieve the comfort temperature for the human being, which is 22.5 to 26, because our ambient temperature is more than 38 or 35. So you'll not feel yourself comfort in that temperature. Like example, there is one software company where you have an open area, bigger area. So in that area, if the temperature is 35 to 40, people will not be in a comfort because they'll be start sweating. But in that, if you provide fan, what happens? Fan is the one which is circulating inside air only. Fan क्या कर रहा है? अंदर के हवा को ही फेंक रहा है. It is not circulating any chilled air. So what we are doing to avoid that, to achieve the comfort temperature, we are going with the concept called as an air conditioning. So the purpose of AC is nothing but to achieve the comfort temperature for a human being, which is 22.5 to 26 is the comfort temperature. So to achieve this comfort temperature, if you provide a fan, it's not going to achieve, because fan is the one which is circulating inside air. So to achieve the comfort temperature for a room, we go with a concept called as an AC, air conditioning. So we all know that ACs are always rated in terms of TR. TR stands for ton of refrigeration. AC, the units of AC is always rated in terms of TR, that is ton of refrigeration. Now there is a small realistic definition for TR. What does a TR means? It is defined as amount of heat extracted by 1 ton of ice to melt completely in 24 hours. Then we called 1 ton of AC. इसका मतलब क्या है? अभी in one room, let us take one room. In that room, if you provide 1 ton of AC, एक ton का ice लगाऊंगा. If you provide 1 ton of ice in that room, what happened to that ice? It will start melting. Why it melts? Because whatever the heat is there inside that room, that heat is absorbed by the AC. That heat is absorbed by the ice. When the heat is absorbed by the ice, what happened? the ice will start melting from a solid state to liquid state. Okay, but the temperature is 0 degrees Celsius, but it start melting from solid state to liquid state. So what is the definition of TR? It is defined as the amount of heat extracted by 1 ton of ice to melt completely from solid state to liquid state at 0 degrees is called as 1 TR. TR stands for ton of refrigeration. Now in this we have a two kind of AC. One is domestic ACs as well as in centralized air conditioning. We have a kind of AC that is nothing but your domestic as well as in centralized air conditioning. Now when it comes to centralized air conditioning, guys, we don't do any calculations. When it comes to centralized air conditioning, we don't do any calculation. Why? Because who will do? Mechanical people. They are called HVAC engineers. That is heat ventilation air conditioning engineers. There's a big topic for the, first of all, what is centralized air conditioning? I think people know. We are not going to put a individual machine for an individual room. There will be a big machine on the terrace. There is a terrace. On the terrace, they are going to put a big machine called as, there will be a separate room, AHU, air handling unit room. There they are going to place a big machine. From that machine, they are going to supply the chilled air to all the rooms with the help of ducting, okay, and they'll put some diffusers or grills. From that grill you'll get a chiller, like you see in the shopping malls. We don't see any AC, but you'll see some grill like structure on the ceiling, and from that grill like structure you're getting a chilled air. That is called centralized air conditioning, okay, because it's a big high-rise building where if you put a machine for every room, then the power consumption increases and it's not accepted also. So they'll go with centralized air conditioning, where with the help of one machine, with the help of ducting, they supply the chilled air to all the complete rooms, okay. That is called centralized air conditioning. But when it comes to a small domestic office, small offices or residential, we can't go with the centralized air conditioning because we don't require that much of things. We go with a split ACs or window ACs that are called domestic. So when it comes to centralized air conditioning, what we do, we hand over the project to HVAC engineers. So what an HVAC engineer will do, they'll do the total calculations. They'll do heat load calculation, ducting calculation, static pressure calculation, kitchen ventilation, car parking, hydronic system, everything, okay, because they'll put chillers, cooling towers, pumps and all. They'll do all the calculations. So when it comes to centralized air conditioning, as I told you, we don't do any calculation. We hand over the project to HVAC engineers. But for that AC, we need to give the power, na? So on what basis you convert that? So when it comes to centralized air conditioning, what is the conversion factor is 1 TR is equal to 3.5 kilowatt. When it comes to centralized air conditioning, 1 TR is equal to 3.5 kilowatt. Okay, so HVAC engineer will say that for my building, the total load capacity is 100 ton. अभी बिल्डिंग को मुझे 100 टन का मशीन आया, तो व्हाट वी डू 100 into 3.5, that is 350 kilowatt. So when you are doing the transformer calculations, we'll add up this load directly in the transformer. वो transformer calculations when you're doing, we'll add up the centralized air conditioning load directly when you're doing the transformer calculation. Okay, then we do the transformer size calculation, and for the 350 kilowatt, what is the cable size, circuit breaker, then we give the supply source to that AHU room so that they will put their own PCB boards and all, they'll start controlling that. But we need to give the supply to that. On what basis? 1 TR is equal to 3.5 kilowatt we consider, and according to that we calculate the HVAC load and we add up in the directly transformer, because we can't give that the 350 kilowatt in dB, no? It should be supplied from the main distribution board panel only. So when you're doing the transformer calculation, we'll directly take the HVAC load and we'll add up the load and we'll do the centralized air conditioning. But when it comes to a domestic cases, we need to calculate like what a split AC and window AC we need to calculate. So to achieve the comfort temperature for residential building, we employ domestic cases called split and window. So for commercial, we employ centralized air conditioning. So now let us see a small overview of domestic cases and what is the power consumption of that. So first of all, what is split AC? Split AC means, as the name itself, we know split means it consists of 2 units. Okay, split AC means it consists of 2 units. One is an indoor unit. Okay, one is an indoor unit, another is an outdoor unit. Indoor unit means you see in your home, inside the bedroom or hall or master bedroom, we'll see a small unit which is inside the room.